So guys, let's continue with the previous thing. We had to do the relationship between gamma and beta. We will follow the same procedure, absolutely zero changes. Okay. So in the previous case, we start with the formula for area, which is nothing but length into breadth. Here we will solve with volume. Volume is equal to length into breadth into height. Now, obviously, we will assume delta T to be equal to 1 Kelvin. This is our standard assumption. And increase in temperature goes from T to T plus delta T. That's the increase in temperature. So when temperature increases, what happens? Volume also increases. If the volume increases, length also increases. When length increases, breadth also increases. Similarly, height also increases. Fine. In the previous case, we saw that the value of delta L was equal to L into alpha into delta T. But since delta T is equal to 1 Kelvin, I will ignore this. Fine. So if delta L is equal to L lambda, common sense is delta B will be equal to B lambda. I'll write here. Delta B will be equal to B into, sorry, not lambda, alpha. Delta H will be equal to H into alpha. So left hand side V plus delta V as it is. One second. Equals L plus L alpha, B plus B alpha, H plus H alpha. Right hand side, I'll take L common first, 1 plus alpha. I'll take B common next, 1 plus alpha. I'll take H common next, 1 plus alpha. Combining them, I'll get L into B into H into 1 plus alpha, the whole cube. Same procedure, V plus delta V as it is on the left hand side. Now, obviously, I'll have to expand. V plus delta V on the left hand side remains. L into B into H remains. Expansion of A plus B, the whole cube, will give me A cube plus B cube plus 3A square B into 3AB square. This is the formula. But at the end of the day, we realize that alpha only is the small value. So automatically alpha square and alpha cube can be neglected because very small values. After neglecting all those things, left-hand side remains the same. L into B into H remains the same. 1 plus, neglect this. 1 plus 3 alpha remains. Now I told you, keep the delta V there itself. L into B into H into 1 plus 3 alpha minus V. Fortunately, we know the answer for V. L into B into H plus 1 plus 3 alpha remains as it is, minus value of V is equal to length into breadth into height. Copy paste that. L into B into H. Now right hand side has two parts. What is common? L into B into H is common. 1 minus 1 plus, 1 plus 3 alpha minus 1 is what remains. Plus 1 minus 1 gets cancelled. Left hand side delta V remains as it is. L into B into H into 3 alpha remains for the answer for delta V. But I'm supposed to find the relationship between gamma and beta. So what do? Next step, I write the formula for gamma. Gamma is equal to 1 by V into delta V by delta T. Previous class I taught you. Delta T's value is equal to 1. This 1 remains as it is. Delta's V's value is L into B. Left hand side is gamma. L into B into H into 3 alpha is what I've got here. Okay. Divided by volumes is L into B into H. Gets cancelled. Gamma is equal to 3 alpha. That's it. Simple, straight to the point. So this will be asked. Next important thing is anomalous expansion of water. The same thing we had learned from 9th standard. I'll explain in very simple language, but obviously important. Graphs are very important. What does anomaly means? What something different is happening at one temperature. What is the temperature? This is 4 degrees Celsius. This is here at 100 degrees Celsius. Okay. Now this is with respect to volume and time. If they ask the same graph with respect to pressure and time, you will do the ulta. P and time, and it will be the highest at 4 degrees Celsius. Both the graphs are important. Now, what's the meaning of it? I'll send the notes, but common sense, everybody knows. When water is cooled from 0 to 4 degrees Celsius, what happens? The volume increases. Okay, sorry. The volume increases and hence the density decreases at this point. But on contrary, when the water is heated from 0 to 4 degrees Celsius, its volume decreases and density increases. That's all. Fine. Same concept what we know in the from our 9th standard, 10th standard, but graphs were not given to us. Graphs are important in terms of definition. Once I send you the notes, just read those 2 lines. Again, what is important here is application of this concept. 2 main applications. One is in cold countries, fish and other creatures remain alive. How? Okay. So you should write this answer. And next is water pipes. Water pipe example. Same old concept. It's there in the notes which I'm about to send you. The reason I'm not going to focus more is because this only will be asked. They might ask you definition. Read through it because the same thing has been there from your ninth standard. But the most important topic which comes to this chapter is the Newton's law of cooling. Whatever happens, please don't skip this. See, there's nothing difficult here, okay? People, it's kind of new. That's why people tend to ignore this. But you guys should not do it, okay? Apart from this, everything else is easy. Queen's displacement law, all those things are there. Okay, before that, we'll finish it off. Two laws are there, guys. 1 second, wait. There's one called as three. Okay, fine. Black body radiation. Black body radiation, all these things are one marker. I'll finish it off. Black body radiation. I'll define it for you. So in simple language, a body which absorbs the entire radiation incident on it. So let's imagine there's a rectangular sheet here and three rays are falling on it. And this specific body will absorb everything. So that's the reason as to why people tell avoid wearing black clothes during summer because black tends to absorb everything. So just imagine your t-shirt or shirt is 100% in 100% ideal in nature, which means how many ever rays hits on it, it is not reflecting anything, it is absorbing everything, which means the shirt becomes more, I mean, the shirt, since it is absorbing heat, you tend to feel more hot. You start sweating. That's the concept. So black body radiation in simple language means a perfect a perfect body which absorbs the entire radiation which falls on it. So this is important. Next is something called as Stephen's law. All these things are one markers. Stephen's law. Will it be asked? Sometimes they ask. Okay. Stephen law, okay, it says that, I mean, it's nothing but the energy of this radiation emitted per unit time. That's all. Okay. And it is always based on a black body. Black body. Fine. So nothing but it emits, no, emit it, the, I mean, the amount of radiation emitted per unit time. So how do we represent it? Energy is represented by H. H is equal to sigma into T to the power 4. Okay. Sigma into T to the power 4. That's all. Won't be asked, not that important, but since it's there in the syllabus, we'll finish it off. Okay. Next similar concept is called as Wien's displacement law. Displacement law. All these things are one markers. Fine. So what does it say? It says that I mean Wien's displacement meaning some kind of distances or some kind of length is involved. They're talking about wavelength here. How do you represent wavelength? I'll write lambda. Okay. So here in this case, always remember Wien's displacement law. It's always the maximum intensity. Okay. It's always the maximum. So I write delta m. So sorry, lambda m. Fine. So it goes like this. According to this law, wavelength of maximum intensity emitted of of the emitted black body radiation is inversely proportional to the temperature. In other language, my bad, is inversely proportional to temperature. So as the temperature increases, the wavelength of emission of the which body of the black body keeps on decreasing. So more the temperature, less the emission. That's the concept of Wien's displacement law. Learn both these formulas, useful for your MCQs. Okay. Apart from that, nothing else will be asked. Now coming back to the main matter, what is important is Newton's law of cooling. Can be a 2-marker, can be a 3-marker, depending on college. Newton's law of cooling. Okay. In fact, these are the most important topics in this chapter. Apart from this, nothing else will be asked. Fine. Understand one small concept here. When will conditions? This will be, you'll be able to apply this specific concept. Okay. Only under cooling conditions. Fine. You cannot apply, again, that's the name says, no cooling. Fine. So it has to be cooling. Fine. Now obviously common sense is, let's say you place a body in the atmosphere. When it is cooling, after cooling, there is some sort of temperature difference, 100%. Temperature difference between whom and whom? The body and the surrounding. Okay. So this is the concept. Now, how does the statement go? Understand properly. It goes like this. When a hot body loses heat to its whom? To the surrounding. So let's imagine there's a hot body. There's a body and it is hot in nature. Okay. It loses heat to the whom? To the surrounding. How does it lose heat? In the form of radiation, also called as heat radiation. Heat radiation, it loses heat. Okay. The rate of the loss of heat is directly proportional to the difference of temperature of the body over the surrounding. I'll repeat that. So when there's a hot body kept in the surrounding, it starts to lose heat in form of what? Heat radiation. Now, this is where the Newton's law of cooling starts off. It says that the rate of loss of heat, rate meaning always with respect to time, rate of loss of heat, okay, is directly proportional to the temperature difference. Temperature difference between whom and whom? Between the body and the surrounding. Between the body and the surrounding. So, if the temperature difference is more, then the rate of loss of heat also is more. Okay, it tends to cool faster. That's what they try to tell. Now, how do we represent this specific 100% the statement will come? Rate of loss of heat is directly proportional to the temperature difference between the body and the surrounding. How do we represent this in terms of, um, what do you call formula? Understand, loss always means minus. So minus d q by dt. Okay, heat basically is directly proportional to difference of temperature. No, so I'll write T2 minus T1. Why is it difference of temperature? I mean, why am I writing T1 and T2? Because it says difference. Difference is always between minimum two things. So one is the body, one is the surrounding. This is the concept which I keep in mind and start off. Now, what are we trying to do here? I am trying to eliminate the proportionality symbol. So minus dq by dt is equal to T2 minus T1. Simple, straight to the point. That's all. So to repeat, what's happening? Hot body placed in the surrounding, it starts to lose heat in form of what? In form of heat radiation. Now, based on this, I come up with a statement. It says what? Rate of loss of heat is directly proportional to the temperature difference between the body as well as the surrounding. Simple, straight to the point. Now, how do you write this? Rate meaning always with respect to time. Therefore, if you see left hand side, it is by dt because it says rate. Why is there a minus? Because the word loss is there. Cool. In this case, we use the letter Q to represent heat. That's all. Okay. Will directly proportional to T2 minus T1. Fine. Now, okay, fine. One thing I forgot. Once we remove the proportionality symbol, we introduce a constant. The constant in this case will be called as K. That's all. Fine. So this is the concept as to how the Newton's law of cooling works. Will there be a numerical based on this? 100% there'll be a numerical. We'll solve all the numericals in one class. But after this, there's one more concept called as greenhouse effect, which almost everybody knows. Greenhouse effect, it's been a long time since we've been learning this, but nobody is trying to apply it. Okay. But what is the meaning of, greenhouse effect? Is nothing but the rising concentration of carbon dioxide in the atmosphere. Simple. Okay. Carbon dioxide is increasing in the atmosphere. Though this concept as a whole is called as in the atmosphere. This concept as a whole is called as greenhouse effect. Will this be asked? I don't think so. It'll be asked. But Stefan's law is important in terms of MCQs. Wien's displacement law is also in terms of useful in terms of MCQs. Remember this. Black body radiation. Without learning black body radiation, we will not be able to derive Stefan's law as well as this. Simple. Newton's law of cooling, 100% 2 marker or 3 marker. I am not solving the numerical because we'll solve all the chapters numericals in one class. Fine. Tomorrow's class, I'll send you one. Derivation of math. It's called as sandwich theorem. That's how the next chapter in math called as limits and derivatives starts off with. Watch this. I sent it on YouTube. Okay. I have edited the video. I sent it on YouTube. Watch that. It's a 15-minute video. Practice it twice. 100% will come for your final exam. 100%. Once you understand that concept only, then I can start with this chapter called as limits and derivatives. And limits and derivatives we'll do offline. Getting it? I'm talking about the questions. But if you're not able to solve the derivation, useless learning the concept. Fine. So watch this, and tomorrow's class I'll send you that what do you call the derivation of sandwich theorem. It's called a sandwich theorem. It is based on math, limits, and derivatives. Once you are done with that, we'll solve the remaining things. In fact, I think day after tomorrow, maybe I'll send you the what do you call? You guys had this trigonometry thing, no? That circle, cos of x, a plus b. That also I'll send you. Save those videos and keep. It's useful. I mean, tomorrow's video is anyways on YouTube. No, just have that link, more than enough. Cool. So finish it off. All the numericals is all in one class.